Hello and welcome to a new video on IGCSE physics. Today we will be discussing magnetic properties. We will start with the topic of ferrous and non-ferrous materials. So what are ferrous materials or ferrous metals? Ferrous metals are metals that would be attracted by a magnet or that can become a magnet. Which of these are non-ferrous? So what you need to know is that iron and steel are definitely ferrous metals, right? So anything that has iron or steel cannot be classified as non-ferrous. So in this case, this choice is wrong. This choice is wrong. This choice is wrong because anything that has iron or steel is definitely ferrous. So the correct choice here would be choice B. Which statement about a magnet is correct? A magnet attracts a gold rod. A magnet does not attract a plastic rod. A magnet never repels another magnet. A magnet sometimes repels an unmagnetized nickel rod. So the only correct statement here is statement B. A magnet does not attract plastic rod because plastic is definitely non-ferrous. Which row states whether each metal is ferrous or non-ferrous? So we already said that iron and steel are definitely ferrous materials, right? So this is definitely wrong because iron is labeled as non-ferrous and C is also definitely wrong because they labeled steel as non-ferrous. So is the correct choice here choice A or choice D? Well, aluminum is definitely not ferrous. Steel is ferrous. So this also is wrong. And this is the correct choice, choice D. In a child's toy, a metal rod is used to lift metal fish out of a toy pond. The fish are magnetically attracted to the end of the rod. There is no magnetic force between the fish. What are possible materials from which the fish and the rod are made? So we want to figure out whether the rod is made of soft iron or steel, and whether the fish are made of aluminum or soft iron. So if they were made of aluminum, they would not be attracted to the rod because aluminum is a non-ferrous metal. So anything that says that fish are made of aluminum is absolutely incorrect. So the fish are made of soft iron, and is the rod made of soft iron or steel? So for the rod to attract the fish to it, has to be made of a permanent magnet or a hard magnetic material. Otherwise, it would not attract the fish to it. So the correct choice here would be choice D. The fish are made of soft iron and the rod is made of steel. Moving on, we will cover now the topic of magnetic field lines. Which diagram shows the pattern of magnetic field lines around a bar magnet? So this is something you should know. The magnetic field lines around a bar magnet look like this. They emerge out of the North Pole and they head towards the South Pole. So this is what they look like. The correct choice here is choice D. The diagram shows a permanent bar magnet placed on a wooden table. A student draws arrows to show the direction of the magnetic field at 4 points. Which arrow shows the direction of the magnetic field at that position? So like we said, magnetic field lines emerge out of the north and head towards the south. Let's draw two, for example. And the direction of the arrows are from the north heading towards the south. So which of these letters correspond correctly to the direction of the arrows that we drew? So for A, it's heading up, but it's supposed to be heading to the right. So A is incorrect. C is heading up, supposed to be heading to the right. So again, C is also incorrect. B is heading out of the south. but our arrows are pointing inwards, so this is also incorrect. D is heading out of the north, and our arrows are also heading out, so D is the correct choice. The diagram shows a bar magnet and 4 plotting compasses. Which compass shows the direction of the magnetic field due to the magnet? Again, let's draw magnetic field lines and compare our arrows to the compass. So let's draw 2 of them like that. And we said that heads out of the north and goes into the south. So the only correct choice here would be choice D again, because D is heading in. A is opposite to our direction, so it's incorrect. C is also opposite to our direction, so it's incorrect. And B as well is opposite to our direction. So the only correct choice here would be choice D. Which diagram shows the pattern and the direction of the magnetic field lines around a bar magnet? So first of all, we said that the arrows should be emerging from the north and going into the south. So this is correct. This is correct in terms of the direction of the arrows. But B and D are wrong because their arrows are going from the south to the north. So it's emerging out of the south, which is incorrect. So which choice is correct? Is it A or C? So they should not be close to each other like this, further away from the magnet. That doesn't make sense because close arrows, if the lines are close to each other, that indicates a strong magnetic field. However, as we get further away from the magnetic field gets weaker. So it's not supposed to be getting stronger as we go further away. It's supposed to be getting weaker. So this is incorrect. And choice A is the correct answer. Moving on, we will now discuss permanent magnets and electromagnets. A student wishes to make a permanent magnet. She has an iron rod and a steel rod. Which rod should she use to make the permanent magnet? And is this rod a hard magnetic material or a soft magnetic material? So there are 2 types of magnetic materials. We already distinguished between ferrous and non-ferrous. And we said that iron and steel are both ferrous materials, and they can be used to make magnets. But what is the difference between iron and steel? Steel is a hard magnetic material used to make permanent magnets. Iron is a soft magnetic material used to make temporary magnets, or what we call electromagnets. Each of these has their different uses, but you need to distinguish between the material from which each one is made. So we want to make a permanent magnet. So we want a hard magnetic material, and this material is steel. And the correct choice here would be choice C. Which statement about a permanent bar magnet is correct? It is made from soft magnetic material. This is incorrect. It repels non-magnetic material. Also incorrect. Field lines cross each other. Field lines never cross each other. They're always parallel to each other. The North Pole repels the North Pole of another magnet. This is correct because similar poles repel, opposite poles attract. So the correct choice here would be choice D. An electromagnet with a soft iron core is connected to a battery and an open switch. The soft iron core is just above some small soft iron nails. The switch is now closed, left closed for a few seconds, and then opened. One possible issue of confusion here is this phrase, the switch is now closed. So we'll discuss this later in electricity, but when the switch is closed, this means that there is electricity flowing through the circuit. When the switch is open, there is no electricity. So this here means that it's open, and the current, the electric current, cannot flow through the circuit. So open means no electricity, closed means you have electricity. And for an electromagnet to work, it needs to be connected to an electric power supply, like a battery, for example. So you just need to understand that switch is closed means it's working, basically. We have electricity. Switch is open means no electricity. All right? So what happens when the switch is closed? Electricity flows through the circuit and the electromagnet is activated in a sense. So the iron nails are attracted to the magnet. It becomes a magnet. The electromagnet becomes a working magnet. So the nails jump up. Once I open the switch, there is no electricity flowing. So it is no longer a magnet, because that's why we said it's a temporary magnet. As soon as I stop the electricity, it stops becoming a magnet. Hence, the nails fall down. So the correct choice here would be choice A. Which metal could be used for a permanent magnet and which metal could be used for the core of an electromagnet? We said that permanent magnet needs steel and core of electromagnet needs iron. So the correct choice here is choice D. What is wrong with this label diagram of a permanent magnet? Obviously, as soon as they said permanent, and right underneath it, we have iron disc, that these two don't work together. Iron makes a temporary magnet or an electromagnet. So what is wrong here? The magnet should be made of steel. Correct choice here is choice C. From which metals are the coil and the core of an electromagnet made? So an electromagnet is basically a piece of metal like this. You have coil wound around the piece of metal. So the coil is wire, and this is the core of it, and the core is always made of iron. So we're looking at either choice A or choice C. To distinguish between them, you just need to know that wires are usually made of copper, not steel. And we'll discuss this further in electricity, but for now, just understand that the coil of an electromagnet is made of copper, not steel. And this is just the norm. So the correct choice here would be choice A. In which way are a bar magnet and an electromagnet similar? A bar magnet and an electromagnet are always magnetized when stored. This is not really true. A bar magnet and an electromagnet can both be used to separate magnetic and non-magnetic materials. This is correct. A bar magnet can be made of steel and an electromagnet uses a steel core. No, that's not correct. We said it uses an iron core. The magnetic field strength of a bar magnet and of an electromagnet can both be varied. Not really. An electromagnet, again, you'll learn this a bit later. An electromagnet depends on electricity. So if you increase the voltage or the current supply, if you increase the electric energy being supplied to the electromagnet, it becomes a stronger magnet. So you can vary the strength of the magnet. However, for a bar magnet, you cannot really control the strength of the magnetic field around. So this is also incorrect. So the correct choice here would be choice B. A bar magnet and an electromagnet can both be used to separate magnetic and non-magnetic material. A train of steel nails and a train of iron nails hang from a strong magnet. The trains are then carefully removed from the magnet. What happens to the trains? So permanent magnets are hard to magnetize and hard to demagnetize. So the magnetism sticks to them in a sense. Temporary magnets made of iron are easy to magnetize and easy to demagnetize. So as soon as I remove the magnet, the bar magnet on top, the iron nails immediately become demagnetized. So the iron nails will fall apart, but the steel nails will stay together. So the correct choice here would be choice C. Only the train of iron nails falls apart. The north pole of a bar magnet is placed in turn next to each end of a rod X. One end of the rod moves away from the north pole, but the other end moves towards the pole. The experiment is repeated with the bar magnet and a different rod Y, but this time both ends of the rod move towards the North Pole. From which materials could the rods X and Y be made? So for the first part, we are told that one end of the rod moves away from the North Pole, but the other end moves towards the North Pole. So this is still a magnet, right? So this is not just something that has been temporarily magnetized. This is a permanent magnet in a sense. So rod X is a permanent magnet. For rod Y, both ends of the rod move towards the North Pole. So this is something that has become magnetized and is attracted to the bar magnet. So this would be made out of iron. Hence, the correct choice here would be steel for X and iron for Y. The diagram shows an electromagnet from which material is part X made. So part X is made from soft iron, as we said before, in order to be a temporary magnet. The correct choice here would be choice B. This brings us to the end of our video. I hope this was of value to you. Thank you for watching.